Hi, hello friends and my dear loving students. I'm Vani Sharma back with Corona series. So कुछ करो ना क्या करना है something to do. So we cannot idle and our beloved Prime Minister Modi ji already extended the lockdown period. It is for us to use by being at home, stay safe, stay healthy, and at the same time use it for good purpose. So let's do together some productive work for the benefit of student community. So this is my another Kuch Corona series. I have tried to take it again, as you know, everything that is inside the four walls, what is available to me. Every day I am thinking what to give you to the society and to the student community. So today I have got some related bio experiments which are really interesting, very simple to do, but maybe or may not be, we will be able to do it in a classroom, we may not be able to. It depends on the necessities and the situation for the teachers. So I don't blame the teaching community. But now that there is a lot of leisure, I thought once for all, I will leave something on the cloud so that forever, universally, certain things are available for the children. And so the methodology I am using is again experiential methodology. So this pedagogy always makes the concept understand better. So that is the reason every day I am trying to improvise my teaching with this method. So now I am here today with certain important ones. Osmosis is one very important function in nature. So first I will brief down what all I am going to say today. I have kept the osmosis requirement here. Then again I have already done on hydrotropism. What plants it can just live on with water and getting attracted, that positive hydrotropism. So I have kept another two more examples today for hydrotropism. Then I am going to do the transpiration here with this plant, and I am going to take you out to show the photosynthesis also, and germination of monocot and dicot through seeds, and the factors that are needed for germination. So these are the simple important concepts that you will be learning through your science books, but at the same time these are all the small experiments which will make you understand better. So to begin with, we'll start with osmosis. What is osmosis? Did you ever hear the word? Otherwise also, osmosis is one very important factor that helps the roots to take the water from the soil to the tip of the plant. So how does it happen? We all know about gravitation. We all know that water always flows down. So is it not sitting on your head that how come against the gravity, against the property of the water, which always flows to a lower surface than from a higher surface, then how come these plants are able to take from bottom to up? This is the question in any study, any thinking mind will immediately think of before they know the answer. The nature is so beautiful. So that is the reason today I thought I will teach you about osmosis process. And of course capillary mechanism also will come into that. So this, all the roots, you can see the so nice tender tip root cap. And again this is a tap root. So from these sides, the water has to be taken by the root, and then that root through the conductivity xylem phloem, it has to go up. This is the simple thing that is okay. Then I can't show with a plant. It is not possible to, you can only understand but you cannot see it virtually. So now I have taken two examples, a very famous example taking the potato, and today I had the watermelon, this one also, so I thought I will experiment with watermelon also. Then egg is also, an egg membrane also is very famous for showing this osmosis experiment. So here, what exactly is osmosis? So to prove that, one I have already scooped and kept, and the other one, how to scoop also you must know. So I am going to scoop right in front of you and teach you how to make the scoop. So you take anything, whether it is a ordinary, see how easily it is to scoop. If you take anything that is available in the house also, this is not anything object that is meant for scooping. But I just thought, okay, this may be suitable, so I am trying to use it as a tool, and it's working very well. So ensure that the edges are safe, there is nowhere a hole happens, and you only scoop and take out the inner matter from the potato. You can do with the egg also. Egg is a little longer process, so I am taking this one. So I have done the scooping of 2 potatoes for comparison purpose. So from this also now I will take out some more and remove all of them. So nice, right? You can see, children, both of them are scooped very well, and only one thin layer is remaining. And I also ensure that nowhere there will be opening on the potato. So these 2 are taken for the purpose of this one. Similarly, the watermelon also, the layer of watermelon, the peel, instead of throwing it in the dustbin, I just thought that let me see whether even this will be suitable for doing the osmosis experiment. I do not know whether it will be successful or not. So now doing this, so what we have to do, we all know that the water will be outside. Atmospheric pressure also matters here, and so I am pouring the water in both of them. I am pouring the water and filling the container with water. That means it is like watering the plants, isn't it? I have done the act of watering the plants. Similarly, here also I am watering the plants. I am in the assumption and ensuring that so nothing is there inside this. So it is a dried one. There is no water that has come into it, and both of them you can see. So here I have kept the salt to make the difference in saturation. So one experiment, I am putting the salt in one potato. I have put the salt and filled it with salt. Similarly here also I have filled it with the salt. So this is purpose. I will tell you now exactly what is the purpose. So there is no water, there is no salt in this and in this, and there is salt in this and in this. So after some times, this is, imagine this water place as the soil like this, and here this as a root. So whenever the water is there, there is a semi-permeable membrane. You know the permission, the word permission, if you know what is understood, semi-permeable means it will only allow one direction, it does not allow the other direction. So it is semi means half like. So the water, whenever the plants ensure that inside with its matter, with its minerals and with its lots of other things, it is the concentration is inside is hyper than outside. Outside, when it is outside, atmospheric pressure also will be acting on that. So there will be a thin semi-permeable membrane coating into for the root. So this will allow all the water, atmospheric pressure, and then also the lower concentration. So it will push it into the root. This, once there is a very thin mechanism will be there, capillary, because there will be vascular, transport things, xylem, phloem, you know conductive tissues. So phloem transports food, xylem transports water. So water going will be always upwards, and then phloem, the food is prepared in leaves, so phloem will send them back. That is how continuously the transportation keeps happening in the plant. So this plant after some time you can see the experiment also, in which the water will come, in which the water will not come. So this will take some time, maybe after 2 days. Again I will show you the difference between this entire salt will become moist, or let's wait and watch instead of my telling away the reason. So what I only try to make it is as if it is like an inside the plant sap will have a higher concentration. So to create the higher concentration, I have put the salt in both of them. And without the higher concentration, the same, it is nothing is there, so it is lower than the outside. So I have kept these two without the salt. So these two are osmosis experiments, and its result you will come to know day after tomorrow for you to understand better how the water against the gravitation and against the nature of the liquid that always flows from higher level to the lower level, the water rises up through the capillary mechanism, and again because of the atmospheric pressure and because of the semi-permeable membrane. All three are important to understand how the water rises up. So this is the one very simple experiment about, so this result I will show you later on. Once the water, we will see what will happen to the water that is outside the potato and outside this thing. So this is a, and what I can tell you about the difference between diffusion and the osmosis. So to next experiment, I will, when I come back with osmosis, I will show you the difference between diffusion and osmosis, where you will understand further better in what way osmosis is different from diffusion. Instead of telling today, since I am following the method of experiential method, where I will actually show you, I don't want to dwell into the differences between diffusion and osmosis. So we will come back for osmosis experiment after 2 days. Hi, a very good morning to my dear friends and my little angels, my loving students for whose sake I started this Kuch Corona series. And yesterday you all know very well that on April 15th, once the period lock-in period is extended, I started with the one experiment, osmosis. Osmosis is not so easy to understand with respect to plants. When I say with simply with the roots, that because of that against gravitation, against the property of water, the water rises from soil to up. But yesterday's experiment, so that is why to make you understand, I wanted to tell you about what is semi-permeable membrane, which allows the water from lower concentration to higher concentration. It is a one direction. Semi means half, permeable means which pervades. So this membrane that is present in the living object, that is allowing this one side, one direction liquid flow. So that is what is called otherwise osmosis. So yesterday, if you remember, I will show you again. We have done experiment with scooping 2 bananas and also 2 watermelon peels. So here is a very quickly, it was a beautiful evidence that we have got. We have put the water inside as if we have poured for the plants watering, and then kept 2, one in which is kept as it is, in the other we have added the salt. Can you, if you see here, I can show you the wetness also here. Is it visible? So this is so much of water, you can see the close-up shot also. So much of water has come into this potato in which we have put the salt. Similarly here also it is still visible. See the dryness on this watermelon. This is first time I have done it. Watermelon peel has become so dry, whereas in which we have kept the salt is so liquidy here. You can see that. See, you can see the water content also very visible. You can see on this also. I can pour it back also and show you for your evidence. See here, I can show you how much of water has seeped into this potato. See, this much of water the plant is taking every day, that means from the soil against gravitation. And whereas you can see this, it has become totally dry. Similarly, This peel also has become totally dry, while this piece has taken the water. See the water that is flowing from it. So if we assume that these peels are like plants, they are taking the water against gravitation through the capillary mechanism, and also because of osmosis, because of the thin semi-permeable membrane that is present, and because of higher concentration inside the sap. Always plants maintain that concentration is higher than outside. And of course, the atmospheric pressure also acts outside will be more than inside the plant. So that is the reason all these three factors, atmospheric pressure, semi-permeable membrane, and the concentration of the sap, from lower concentration to higher concentration. So these three factors will add to the process of lifting the water up. So this process is called osmosis. I hope it is very with this experiment, I sure confident that it will be very clear for all of you what is osmosis. Then once you know what is osmosis, you should also know what is diffusion. Have you heard did you hear the word diffusion before in class? Generally diffusion is actually a common word. We generally use it as an English term also. While osmosis we use it only as a science term. You use the word diffusion many times. Diffuse the tension like that and all, which we have to reduce, we use the word diffusion. So it's a general term. So but scientifically, since we are going through the experiments, I am trying to explain you what is actually diffusion and what is the difference between a diffusion and osmosis. So for that I have taken plain water here, and to make it very appealing for you and to make it look colorful, I am going to add a few drops of a red color. You can see how that red molecules are slowly taking the place of intermolecular spaces inside the water. And then now I am going to add blue color from this corner. See the diffusion taking place. Such beautifully it has gone down, and now slowly wherever the space is available between the molecules, these blue color molecules are trying to mingle within the space that is available. So this happens intermolecular space. We use the word. You all know that water, every matter is made up of molecules, and I am trying to add a green color also. It is not so green, but I see the combination. See how beautiful colors and then movement is happening. And there is a ring formation. I will tell you later on why it happened also. See, slowly at the bottom, the blue is trying to settle down, and then again if I add red, again that will go and try to take its space. Like clouds they are forming in the water. That is because always in a liquid there will be space between the molecules. So it is called intermolecular space. So because there is space, still space, like you are on a table, suppose on a desk of 4 children, 3 children are sitting. So there is space for one more child to come and sit. So what will you do? You will move little aside, and then you will give place for the 4th child to sit, if it is your good friend. Or if you still want to accommodate one more friend also, you will still push each other and adjust and allow one more child also to come inside and sit on your same desk. That is called adjustment of space. So this is same thing if we use the word intermolecular space. So that is why these other matter, the liquid forms, are trying to go and occupy the space, and then they are trying to adjust. And like cloud like situation is happening inside, and so this type of mingling, random mingling, there is no order, And after finishing this difference, I will tell you why this cloud has taken place. Up that ring also has taken place. Again, I am adding a little more of green. Wow, it is like an experimenting for rainbows. Are you able to see? Now keep guessing why that top layer has happened. Keep guessing till I finish you the explanation between the diffusion and osmosis. Any guesses so far? Keep thinking till the end, till I tell you why that layer, the top layer, is taking place. I'll keep adding some more also for your convenience. The more any amount of this thing liquid I add, it's fun to see the color clouds that are taking place. Are you enjoying it? So now that you have got enough entertainment factor and nice cloud formation, multicolor, beautiful liquid that has taken place, now we'll come to the explanation. So here, as I already told you, it's a liquid and we have added the liquid. And there is space between the intermolecular space in these liquids also, intermolecular space in the water also. So because of that, these places have taken place and they occupied that place. So it is random. There is no rule or rhyme. And here there is no semi-permeable membrane. For osmosis to take place, a semi-permeable membrane is a must. So it is between only the liquids, inner sap that is present in the plants and outer minerals and outer water. So this happens from lower concentration to higher concentration through the semi-permeable membrane. That is the fundamental difference between osmosis and diffusion. In diffusion, is there any semi-permeable membrane? No. We have just added multiple colored liquids one upon the other to another liquid. So it is randomly where and why, it is like a crowd. In crowd, what happens in the bus stand or railway station and all, wherever the space is there, people will quickly go and occupy. That is what is diffusion. Whereas in semi-permeable, it is not possible like that. There is a structured movement of liquid from lower concentration to higher concentration. So that is the first main difference is semi-permeable membrane is required here, not required here. And here it happens only in transfer of liquid. It doesn't happen in other. In case of diffusion, now I keep this liquid to liquid aside and I will show you another example of liquid to solid also and gas to gas also, because diffusion can happen in any matter, in any form the matter is, it will happen. There is no rule or rhyme for it. So here that takes some time for the egg to come out. So I have taken some mud and added in water and kept ready. So you can see the bottom layer is solid and top layer is liquid. This is solid, this is liquid. So I will try to mix it now. Is it getting mixed or not? So this is between solid and liquid, diffusion is happening. Now as another example, air, last time also I have shown you, I cannot show in any other form. So I have taken some air I have created around, and then this air is going and occupying the intermolecular spaces of the air that is around it. So slowly you can see the air bubble, it is like somewhere and all, it is going wherever it is getting the space. You have to understand, it is when whichever direction it is going, that means that there it is more intermolecular space for it to go and occupy that space. So diffusion is a random movement. There is no order for it. Randomly, wherever it is like a running from after the school, once the school is over, the bell rings, how you run away from the school with super speed. To come into the school, you come slowly. There will be order, there will be queue. So from assembly you will join, from assembly you will go in order to your classrooms. So it is a very crude example but makes sense for you to understand. So that is why osmosis is more orderly and structured from lower concentration to higher concentration through a semi-permeable membrane. It happens only between two liquids. Whereas diffusion is a random movement. It has no order. Wherever there is space, it will go run and occupy. You can see the entire air that what we have created has spread over the air around and creating a mixture of gases. So similarly, we have taken the solid and liquid. Here also it got mixed and then became one suspension. This type of liquids are called suspension because it is not solution. If it is a solution, it will mix so well that you cannot differentiate between them. Whereas here, though they got mixed, they will again settle down and become two layers. So this type of mixers are called suspensions. So I will tell you, then this again, whatever the water we have got, this is a pure liquid. You can easily, the transparency and the visibility is there. So emulsions are different. Emulsions means where there is an oil content in that. And now you are curious to know why it is like this, isn't it? Why the top layer is greenish and it did not mix at all. You still want to know? You still have that doubt in your mind and want to know it really? Then I can tell you, because I have taken two watercolors and one fabric color. So fabric color is oil based. So once one oil is there, oil will not mix with the other liquids because oil it's an emulsion. So because of that, this green color, though it is there, it has become a top layer and it did not mix with it did not go down because there is a little slight oil in that. So these two are immiscible liquids. So that means what? Miscible means mixes, immiscible means does not mix. There are various reasons. Oil and water is one thing, they don't mix. Then there will be, depends on the density also, they don't mix. Denser object will go down, lighter object will float. There are various, again the various other factors are there. So this such a beautiful top layer, greenish top layer has taken place because it is not a liquid, it is an emulsion. So even in the liquid state also I could tell you the differences, suspension, pure liquid and emulsion. So these are the varieties of liquids and the basic differences between the osmosis and diffusion you have learned with the examples. And in the diffusion again you have seen the liquid to liquid, you have seen liquid to solid and you have seen gas to gas. Then you can again, whether it is solid to liquid or liquid to solid becomes the same. And then gas means anywhere, everywhere there will be gas also inside this. Sorry. So I have given you the beautiful, within my limitation of getting the material in the house, thanks to again lockdown, I am making optimum usage of this lockdown period and coming out with new ideas to help you all. I am sure even the B.Ed teachers who are undergoing training also will make good use of these videos which are on cloud and YouTube. So thank you, bye bye, see you with another experiment. The next experiment that I am going to come with the separation of mixtures. Thank you, bye bye, see you.